Bismillah ar-Rahman ar-Rahim. Now we'll start this 4.4, which mainly we are talking about concavity and the second derivative test. Okay. As usual, we'll start by the common terminologies or the common things in that section, and then we'll go to the problems. Okay. We define what is the meaning of concavity. If you have a differentiable function, the graph is concave up. If f prime is increasing, f prime increasing means f prime positive. F prime decreasing means f prime negative. So what's the test for concavity? If f double prime positive, then we say f is concave up. I have a continuous function. What his second derivative exists. And if double prime negative, then I have concave down. Okay. To apply this theorem, I need to do what? First, we locate the x values at which f double prime equal to 0 or f double prime does not exist. Use these x values to determine the test intervals. As usual, plus the point of discontinuity. Plus points of discontinuity. Because I need them. Okay. When there are x values, the function is not continuous, it should be used, as I said, along with these points to form the test intervals. Also, we define what's called point of inflection. What do you mean by point of inflection? F is continuous. C is the point in the interval. The graph has a tangent line at this point C. Then we say this point of inflection when, if there is a change of concavity, up to down or down to up. And how to start with the point of inflection? We'll start with if double prime equals 0 and if double prime doesn't exist. We'll start with these two. Then we'll check there's a change in the concavity or not, or also the other conditions being the function is continuous at this C. Second derivative test. If I have f prime equals 0, then f prime equals 0, only for f prime equals 0. Then I check f double prime. If it is positive, then I have a relative minimum. If f double prime negative, then I have a relative maximum. Note, f double prime positive, relative minimum. F double prime negative, relative maximum. 0, test fails. Test fails. We have no conclusion. We need to go back to the first derivative test. This is mainly the thing. So we have concavity when the function is concave up or concave down. If double prime positive, if double prime negative. And how to apply the test? We need to start with these test intervals are what? If double prime equals 0, and if double prime doesn't exist, and also the point of discontinuity. Point of inflection, I will start with this, if double prime equals 0, or if double prime does not exist, and then I will check the other conditions about the inflection points. If continuous, the function is continuous, and there is a change of concavity, up to down or down to up. And there is this second derivative test, which is only what if the f prime is equal to 0. For f prime at c equal to 0, then I check f double prime. Positive, relative minimum, negative, relative maximum, 0, test fails. Let us do some problems. Okay. Find the intervals where the function is concave up or concave down. I will check the sign of what? Of f double prime. So it means I need to do what? I need first to find f double prime. This is going to be my first step. So we'll do f prime will be what? F prime will be x squared minus 1. What about f double prime? F double prime will be 2x. Now I will check the sign of this. So check when f double prime at x equals 0. So I have x equals 0. So I'll put the number line. This is 0. And I will check this function. Before 0, it's negative. This is positive. Now this means concave down. This means concave up. That's it. That's concave down from minus infinity to 0. And concave up from 0 to infinity. Concave. I'll use CD, CU. After that, I'll use CD and I'll see you. Okay, I think it's very clear, easy to do. Usually just will change the function, we'll try to do the calculations. Now what will be f prime here? F prime will be eus minus x squared over 2 times derivative of this, derivative of u, which is minus 2x, or minus x, minus 2x over 2. So it's minus x. So this function, this is the derivative. I'm not looking for the derivative, I'm looking for the second derivative. What will be the second derivative? We'll do the calculation. Derivative of this, which is minus 1, eus minus x squared over 2, plus minus x, derivative of this, eus minus x squared over 2, times minus x. So that'll give me what? X squared minus 1 times eus minus x squared over 2. By the way, it's a domain of f or real numbers. So you have no problem at all. Okay, so that if I have f double prime equal to 0, I have x squared minus 1 equal to 0. So I have x equal plus or minus 1. So I put the number 9, this is minus 1, this is 1. This is what I will check. This is always positive. I need a check only x squared minus 1. That will be what? Positive, negative, positive. So it's concave up, concave down, concave up. Okay, so it's concave up from where to where? Cu from minus infinity to minus 1, and from 1 to infinity, CD from minus 1 to 1. Okay, we'll do more problems. As I said, as in 4.3, the idea is very simple, but now each problem, it has its complexity. I have the domain of f, all real numbers, except plus or minus 2. Okay, now check f double prime. We'll do f prime. F prime would be 2x, x squared minus 4, minus 2x, x squared plus 1, over x squared minus 4 squared. Okay, that give me what? 2x cubed minus 2x cubed, mas salama. I have minus 8x minus 2x. That give me what? Minus 10x over this. Okay, now we'll do f double prime. It has what? Minus 10 x squared minus 4 squared minus 10x to x squared minus 4 times 2x over x squared minus 4 to the power 4. Okay, I can take x squared minus 4. Also, I can take 10. I can take 10 x squared minus 4 as a common factor, or minus 10. Yeah, take a 10, no problem. Okay, so I have what? Minus x squared minus 4. And I have what? Plus 4x squared. Okay. Over x squared minus 4 to the power 4. So this is cancelled. This is 3. So I have what? 10. 4x squared plus minus x squared. That would be 3x squared plus 4 over this. Okay. Now I have point of discontinuity, which is x equal minus 2, x equal 2. So here, f double prime equal to 0 will give me nothing, huh? Because this is always positive, huh? So I have nothing if double prime equal to 0. So what I will do, I have only minus 2 and 2. Check the sign. This is always positive. This is what will make the effect. And that take minus 3. It will be positive, negative, positive. So it's concave up from minus infinity to minus 2. And from 2 to infinity. Concave down from minus 2 to 2. Okay, we'll do more problems. Now we'll discuss the points of inflection. Now we need also to find the points of inflection for this function. Okay. Now I have f prime for x cubed minus 12x squared. F double prime, I have 12x squared minus 24x, which is what? 12x, x minus 2. So f double prime equal to 0. By the way, the domain of f or real numbers. That implies x equals 0 or x equal 2. So I'll put number 9, 0, 2. I'm going to check the sign of this function. So before 0, take minus 1. It will be negative, negative. That will be positive. 1, it will be negative. That will be positive. So it's concave up, concave down, concave up. Concave up from minus infinity to 0, and from 2 to infinity. Concave down, 0 to 2. Okay. Do you have a inflection point? Inflection point comes from where? Comes from double prime equal to 0. And there is a change of concavity. Yes, there is a change here. So I have a inflection point here. And there is a change here, down to up, and up to down. So also there's an inflection point here. So inflection point at x equals 0 and at x equal 2. Okay. Consider the function this one, the terms of concavity and inflection point. Okay, easy one. What you will do, the same thing, find our real numbers, domain of f or real numbers. Find f prime. That will be 3x squared minus 3. Find f double prime. That give me what? F double prime will give me 6x, correct? Yeah, this is 3x squared. That will give me 6x. Okay, 6x, that means what? I check the sign now. The sign of this. I have f double prime equals 0. Very clear. X equals 0. So I will plug this. For x equals 0, I have 0. Before 0, it's negative. That's positive. So it's concave down. This is concave up. So it's concave down from minus infinity to 0. Concave up from 0 to infinity. And I have a inflection point here. Inflection point at x equals 0. Which is the inflection point we want to try. Just substitute, 0 and 2, which is easy to do. Okay. Because the function, find the interval of decreasing, increasing, local maximum, everything, Okay. So that's a little bit lengthy. Let us do it. I have f prime, the domain or real numbers. So I have f prime. F prime will be what? 4x cubed minus 48x. I can take 4 common factor for x, actually. I have x squared minus 12. Critical numbers. I'll find f prime equals 0. That implies x equals 0 or x equal plus or minus square root of 12, which is plus or minus 2 square root of 3. So I can do the for increasing and decreasing. I'll do this minus 2 square root of 3, 0, 2 square root of 3. Check the signs. That give me what? I want to check this function. So take a value here, for example, minus 4. That will be negative. Here it will be positive, negative, positive. So it's increasing, decreasing, increasing, decreasing, increasing. So you have local minimum here, local max. I have local min here. Okay, f double prime will give me what? Derivative of this, 12x squared minus 48. And that give me what? 12x squared minus 4. Okay. So f double prime equals 0 will give me x equal plus or minus 2. So do the sign diagram, the test intervals. This is 2. I have to check this function. Minus 3, it will be positive, negative, positive. So it's concave up, concave down, concave up. And these are inflection points. These are inflection points. Since there is a change of concavity, up to down or down to up. Now the function is a little bit different. Let the polynomial will do the same thing. So I have, let me see, okay, domain or real numbers. Nothing to worry about. F prime will be what? Ax plus x ax, which is 1 plus x ax. F prime equals 0, critical numbers. X will be minus 1. These are critical numbers, so I'll put minus 1. Before minus 1, it's negative. Then it's positive, means decreasing, increasing. I have local min here, local minimum here. Okay. Now, f double prime, if we do the calculation, you have what? Ax plus 1 minus 1 plus x ax. So it will be 2 plus x ax. F double prime equals 0. So I have x equal minus 2. خلاص, like the minus 2. Before minus 2 is negative, this is positive, so it's concave down, concave up, and this is an inflection point. Okay. Sketch a possible graph of a function that satisfies the following. Okay. Now it's the other way. I give you some information, and I want you to sketch the graph. Okay. F prime is positive, that means increasing, and this is decreasing. In f double prime is positive, and this and that, so it's concave up, and this is concave down. The limit minus 2 and 1. Okay, I can do one thing. I can check what are the points which is concerned me. These are minus 2, and also I have the 2. This is for the concavity, and I have 1 for the increasing and decreasing. So before 1, it's f. I'll do the derivative of the sign of f prime. I mean above the line, the sign of f double prime below the line, so that I can do it and the same thing. So before 1, the function is increasing. So I have increasing, increasing. After 1, the function is decreasing. Okay. It's concave up from minus infinity to minus 2. This is concave up. F double prime is positive. From minus 2 and from 2 to infinity, also concave up. From minus 2 to 2, it's concave down. Okay. And I know that there is an asymptote here. So I have y equal minus 2 is a horizontal asymptote, and y equals 0 is a horizontal asymptote. Okay. Let me sketch the curve. This is not only one answer, it has a lot of answers. Okay. So I have y equal minus 2. This is an asymptote. And y equal 1, which is the x. Y equals 0, which is the x-axis. Okay, what are the important values? Minus 2, 1, 2, which is the same as the number 9. Okay. It says what? Before minus 2 is increasing and concave up. And this is the asymptote. So it will reach this. It will reach this. It means it will do something that's concave up and increasing. It will do something like this. Up to here. Somewhere here, up, who cares? Okay. And then from minus 2 to 1 is concave down and still increasing, but it will do something like this, like if it's concave down, huh? Concave down up to 1. Up to 1. Okay. Then at 1, we'll do what? It will go down and concave down, still concave down. Up to 2. 2, it will do what? Concave up and decreasing. So it will do something like this. But don't forget, as x goes to infinity, this is the asymptote, y equals 0. That will do something like this. Okay. Now I will do the second derivative test. I'll do example for the second derivative test. Okay. Now we'll do f prime. Will be what? 4x cubed minus 48x. And that will be 4x, x squared minus 12. Make it equal to 0. Don't forget second derivative test. I'm dealing with a prime at c equals 0. Huh? So I have x equals 0 or x equal plus or minus square root of 12, which is plus or minus 2 square root of 3. Okay, now we'll find f double prime. It will be what? 12x squared minus 48. Which is, just to make the calculation easier, to find the sign, I have what? 12x squared minus 4. Okay. Now I'll check these values, these 3 values. F double prime at 0, give me what? Minus 48, negative. So I have local maximum at x equals 0. F double prime of 2 square root of 3. That give me what? 2 square root of 3, which is square root of 12. 12 minus 4, that will give me positive. I don't care what is the number, but I care it's what? Positive value. So I have local min at equal to square root of 3. Okay. F double prime of minus 2 square root of 3. That will be what? Also 12 minus 4 positive times 12, still positive. So I have local minimum at x equal minus 2 square root of 3. Okay, that's the second derivative test. Find the relative extreme of this function. Now we need to find the relative extreme of this function. Okay. So how to do this? To do this, you can do it in 2 ways. One way, through f prime and find the sign diagram. The other way is through the f double prime. So I have f prime. The domain is all in numbers. Huh? So f prime will be what? Minus 15 x to the power 4 plus 15x squared. Okay. And f double prime. No, this one is what? I can simplify it. I can take 15x squared common factor, and I'm getting what? 1 minus x squared. Okay. So critical numbers, it means the critical numbers when f prime is equal to 0, that implies x equals 0 or x equal plus 1 or x equal 1. F double prime would be what? Minus 60 x cubed plus 30x plus 30x, yes. In other words, it's 30x times what? Times 1 minus 2x squared. Okay. Now if I check through f double prime, I check these points. F let me start backward. F at 1 will be what? 30 negative. It's a negative value. It will be 30 times 1 is minus 1. So it's minus 30. So it's negative. So I have local max at x equal 1. F at minus 1 will be what? Will be positive. F at minus 1 will be positive. That will be negative, and that will be negative. So it will be positive. So I have local min at x equal minus 1. What about, I'm talking about f double prime, sorry. This is f double prime. At 0 will be what? Will be 0. That means what? Test fails. So what I need to do first derivative test. Okay, if I do the first derivative test for 0, it will be what? And what is this? I have minus 1, 0, 1. Check the sign. The effect is here. This one always non-negative. So the effect is here. Take minus 2. It will be negative. Minus 1 to 0. We'll take minus half. It will be positive. That is still positive. This will be negative. So 0, no, neither. Relative or local, since I'm using the word local. Local min, nor local max. I cannot conclude from the second derivative test. I can conclude only from the first derivative test. Okay. Use to find the local maximum with the second derivative test. You want me to use the second derivative test in this case. So we'll do f prime. Let me do f prime. So f prime will be the domain oriented numbers, huh? Nothing to worry about. F prime will be 5x to the power 4 minus 15x squared. This is f prime. So f double prime. Okay, I'll find the zeros first. So I have 5x squared. I have x squared minus 3. Okay. So f prime equals 0. That implies x equals 0 or x equals minus square root of 3 or x equals square root of 3. Now find f double prime. That will be what? 20 x cubed minus 30x. Can take 10x common factor. I have what? 2x squared minus 3. Okay. Now check f double prime of square root of 3 will be what? This is positive. This is positive. That will be positive. I don't care about the value. We care only positive. So I have local minimum here at x equals square root of 3. F double prime of minus square root of 3. That will be negative. That will be positive. So that will be negative. So I have local min at x equals minus square root of 3. But when I check f double prime at 0, I'm getting what? 0. That means test fails. That's it. Test fails. I'll need to do first derivative test, which will show you إنه at x equals 0, neither local max nor local min. But you need to do it. Okay. Yeah. Discuss the curve and then sketch and try to sketch a function. And I need to combine all of these things in one graph. Okay. Yeah. By the way, I think we can do first derivative test, huh? I will leave it, huh? Okay, let me do this one. Now I need to do everything, huh? Increasing, decreasing, concavity. Then I need to sketch the curve also, which is actually 4.6, but we can do it here. So the domain orient numbers, very clear on us. F prime will be what? 4x cubed minus 12x squared, which is 4x squared times x minus 3. Critical numbers, f prime equal to 0. So I have x equals 0 or x equals 3. Put it 0, 3. Take a value for 0, it will be negative, negative, positive. So it's decreasing, decreasing, and then increasing. I have only local minimum as 3. Local minimum as 3. Okay. Check f double prime. F double prime will be what? 12x squared minus 24x, which is 12x times x minus 2, equal to 0. So I have x equals 0 or x equal to. So do this 0, 2. It's before 0, it's positive. 1 negative. This is positive. So it's concave up, concave down, concave up. And they have inflection points here. Okay. Then he wants me to graph the function. To graph the function or to sketch the curve. What I will do as a step, I will combine these two in one. I have the 0, I have the 2, I have the 3. I will do f prime here and f double prime here. Before 0, this is negative. Between 0 to 3, it's negative. And this is positive for f prime. F double prime before 0, it's positive. Between 0 and 2, it's negative. More than 2, it's positive. Okay. It means what? Now, if I want to graph the function, I will add one thing. Or let me do the graph of the function in the next page. I'll take this with me. So I have what? 0, 2, 3, minus, 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 plus. This is f prime. You can do it instead of minus, minus. You can do it like decreasing, 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 and this is increasing. For f double prime, plus, minus, plus, plus. For f double prime is concave up, concave down, concave up, concave up. Okay, I will add the intercepts. This is what I will add. What is the function? Y equal x to the power 4 minus 4x cubed. In other words, it's x cubed times x minus 4. So for sure, y-intercept will be 0, 0. I'll put x equals 0, it's very clear. X-intercept, I will put y equals 0, so I have the point 0, 0, and 4, 0. Okay. So I'll graph the function now. And I have all of this information. So I have 0, 0, and I have 4, 0. Okay. Before 0, the function down and concave up. It's down, concave up. I need to check, take a value, negative value, for example, -1. I want to check it's here or there, the graph of the function. So take -1, it will be -1 times minus, that will be positive. So the function is going down and concave up. Do something like this. This is the way the function. Now between 0 and 2, it still go down, but concave down, up to 2 here, 2 here somewhere. So it will do something like this, up to here. And then from 2 to 3, it's concave up and still down. Instead of going down like this, it will do something like this. Up to 3, sorry. Up to 3. 3 here somewhere. At 3, it will go down up, but concave up also. It will do something like this. But this is 4. Let's go back. Okay. So I have here a local minimum. Local minimum. And actually absolute minimum. So this is the graph. Oops. Limited above another. Control M. Sorry, yeah, this is the function f(x) equal x to the power 2 over 3 times 6 minus x. I will do it here. X to the power 2 over 3 times 6 minus x to the power 1 over 3. Is it? Yeah. Which is an interesting function. Let us do the calculation. Do the same thing. All of this calculation to check this function. Okay. So I need to do all of the, I want to sketch the graph. So I need to find f prime, f double prime, all of these things related to this function. Oh. Okay, domain or real numbers. F prime. I think you know how to do F prime. Let me take it. 4 minus x to save time. X1 over 3. 6 minus x to the power 2 over 3. That's the F prime. So critical numbers. I have x equal 4 from here. And from here, I have x equal 0 and x equal 6. Okay. So that gives me what? Increasing, decreasing. We'll make it in one graph. That will be 0. That will be 4. That will be 6. I'll check the sign of this function. Huh? Don't forget you are checking the sign of this function. This is always non-negative. Huh? Positive actually, since the power is 2. So this is what will control. This and this will make the control. So take a value negative. That will be positive. Negative. That will be negative. When between 0 and 4, that will be what? Negative over, no, that will be positive over positive. That will make it positive. Okay. Now, between 4 and 6, 5, for example, that will be negative, positive, that will be negative. More than 6, negative, positive, still negative. So it's decreasing, increasing, decreasing, decreasing. So I have local min, I have a local max. Do you have a local minimum at 0? Yes, because the function is defined as 0. The function, the original function. Okay. Now we'll do the second derivative. If we do the calculations, you will get what? You will get minus 8 over x, 4 over 3, 6 minus x to the power 5 over 3. I'm saving the calculation. So what are the points which I will make here? It will be 0 and 6. The function cannot be 0, but I have this point where the f double prime does not exist. So we'll do the sign. This is always positive. Huh? So it will be what? Minus 0. Before 0, take a negative. That will be positive. Negative, that will be negative. Between 0 and 6, take 1. Still, it's negative. More a 6, it will be negative, negative, that will be positive. That's concave down, concave down, and this is concave up. Let me put it in one graph, all of these things, 0, 4, 6. We'll make it in one graph. I think it will make our calculation easier. What you will get, I have f prime here and f double prime here. It will be decreasing, then increasing, decreasing, decreasing. For concavity, concave down, concave down, concave down, and this is concave up. Okay, now I'll graph the function. Now we'll try to graph the function according to this. What are the intercepts? Very clear, the intercepts. Intercepts. I have 0, 0. This is the y-intercept. And I have for the x-intercept, I have 0, 0, and 6, 0. Okay, now I'll graph the function. So for the x-axis, I know I have 0, 0, and 6, 0. This for the x-axis. Now, before 0, take a value, negative. You're getting what? Negative, positive, that will be positive. And it's what? Decreasing and concave down. So it decreases, but it'll go like this. Where is concave down, and decreasing. Okay, between 0 and 4, it's going up and concave down, still concave down, but going up to 4. Or I don't have zeros, but up to 4 here. I need the 4, so it will be something like this, going up and concave down, up to 4. At 4, it will go down and concave down still. That will do something like this, up to 6. Then from 6, it's concave up and decreasing. So it will do something like this. Okay, so this is a sketch of the graph. Another function, e to the power 1 over x. The only things remaining here, the only things new, I have asymptotes here. I'll do the same, but now I need to add the asymptotes. You notice for f of x, e to the power 1 over x. First, I notice there is a problem at x equals 0. The domain of f, all real numbers except 0. So 0 is the point of discontinuity. So if we check the limit, as this goes to 0 from right, you're getting what? E to the power infinity, and that's infinity. When x goes to 0 from right, 1 over x goes to infinity. And limit x goes to 0 from left, that will be e minus infinity, which is 0. So I have a vertical asymptote. X equals 0. Okay. Oh, I have vertical asymptote from here. From here, I have vertical asymptote from right. Okay. Also, I check the limit as this goes to infinity for this function. That will be e to the power 0, which is 1, and the limit as this goes to minus infinity, which is the same, it's 1. So I have horizontal asymptotes, y equals 1. Intercept, no intercept. No x-intercept, no y-intercept. خلاص? Okay, now we'll do f prime. We'll check the sides. Let me take it from here. That will be what? Minus e1 over x squared. Yeah. That's always negative. You notice this is positive times minus, so this is always negative. Means what? Means the function is decreasing. But I need to be careful. When I put the number line, I need the 0 to be open. So it's decreasing from minus infinity to 0, and from 0 to infinity. Take f double prime. Do the calculation, you get this. So I need to worry about what? 0, minus half, and 0. Okay. Check the sign diagram. Take minus half. You notice this is positive, this is positive, so this is make the effect. So before minus half, it will be negative, and then it will be positive, positive. So it's concave down, it's concave up, this is concave. Now we'll put it in one diagram. I have minus half and 0 open. For f prime, for f double prime. Oops. For f double prime. For f prime, it's decreasing all the way. Decreasing, decreasing, decreasing. For f double prime, it's concave down here. Then it's concave up. Then it's concave. Now I'll graph the function. Now I'll graph the function. Okay, asymptotes? No asymptotes. No intercept, I mean. No intercept. No intercepts. So I need to do what? The asymptotes. I have horizontal asymptote, y equal 1. خلاص. Y equal 1. That is 1. And that asymptote will not, will it be crossed? No, it will not be crossed because e to the power 1 over x cannot be equal to 1. Not e to the power 1 over x cannot be equal to 1. Okay. Because 1 over x cannot be equal to 0. So that will not be crossed. There is no point of intersection between the curve and the horizontal asymptote. Okay, now we'll take a value. This is the values are 0. That's it. That's this is the value. And here, decreasing with the change of concavity. Okay. So take a value before 0. Take, for example, minus 1. What is f of minus 1? It will be eus minus 1, which is 1 over e. 1 over e is something less than 1. So it will be the curve will be here. So it will do something. Do something that, and it's what? Before minus half, it's decreasing on concave down. So it will be decreasing on concave down up to minus 2, up to minus half, where it will do what? It's still decreasing, but concave up. And this is not defined at 0. And then after that, on the other side, after 0, it's going down and concave up. So it's going down and concave up. I have a vertical asymptote at 6 equals 0 from the right side, as I said here. From the right side, I have vertical asymptotes. So this is the curve. Okay. Yeah. I'll try to do these 3 problems before I do these multiple choice questions. Okay. What is the domain here? Domain of f. It will be from minus infinity to 2. Okay. Intercepts. Very clear. 0, 0 as a y-intercept. 0, 0 and 2, 0 as x-intercept. Okay. Now we'll do f prime. Or I will use the one. It will be 4 minus 3x over square root 4 minus 2x. So critical numbers. I see here f prime equal to 0. I have x equal what? 4/3. Is it in the domain of f? Yes, it's the domain of f. So it's a critical number. So I'll do the sign diagram for, notice this is up to 2. So I have 4/3 somewhere here. Take a value, 4/3, it will be positive, and this is negative. So it's increasing and then decreasing. I have a local minimum here. Local max. Okay. F double prime. If we do the calculation for f double prime, you will get what? 3x minus 8 over square root 4 minus 2x all cubed. So f double prime equals 0. Gave me x equal 8/3. Be careful. This does not belong to the domain of f. So I'll put now critical numbers. Is there a critical number? No. This is 2. 2. So this is always negative. So it's always negative. So it's negative. So it's always concave down. All the way. It's concave down. Okay. Now let you combine this in 1. I have 4/3. And I have 2. F prime. It's increasing, then decreasing. F double prime. Concave down, all the way, concave down. Let me grab the function now. This is the function. I'll put everything. This is 0, 0, and this is 2, 0. Okay. Before 0, before 4/3, actually, not only before 0, before 4/3 is increasing and concave down, increasing, concave down. So it will do something like this. Increasing, concave down, up to 4/3. When it comes to 4/3, it will do what? It will be decreasing, but it's still concave down like this. So this is a half local maximum. Actually, it's an absolute maximum. So that's the graph of the function. And it's up to 2. Let me do this function. Now, in this function, what is new? I have asymptotes here. Okay. So what's the domain of the function? All real numbers except plus or minus 1. By the way, intercepts 0, 0. This is y-intercept. And x-intercept, actually. Same thing. X-intercept. Very clear. Asymptote, horizontal asymptote, same degree, y equal 1. Vertical asymptote, x equal plus or minus 1. خلاص. Now we'll do f prime. What will be f prime? F prime, let me take it from here. It will be what? F prime. It is minus 2x over x squared minus 1 squared. And this is point of discontinuity. Huh? So I check the sign diagram. I have minus 1, 0, and 1. Okay. So before minus 1, take a value negative. Actually, this make no effect. Huh? This what will do the effect, minus 2x. So negative will be positive, positive. This is negative, and this is negative. So it's up, up, down, decreasing, decreasing, increasing, increasing, decreasing. I have local maximum here at x equals 0. Okay. There's only one critical number, which is x equals 0, because it's the other one is not defined. Minus 1 and 1, the function is not defined. I'll do f double prime. Let me take it from here. That will be what? 2 x squared plus 1 over x squared minus 1 cubed. Okay, so to do the sign diagram, this cannot be equal to 0, the numerator. So do the sign diagram only for minus 1 and 1, where they are not defined. Okay. So before minus 1, that will be positive. This will make the effect. That will be positive, negative, positive. So it's concave up, concave down, concave up. Let me put it in one diagram, one number now, one test interval, 0. This is 1. I have f prime, I have f double prime. F prime, it's increasing, then decreasing. This one concave up to -1, then concave down, and this is concave up from 1. So now I graph the function. I'll put everything now. Intercept, I have 0, 0. I have vertical asymptote at -1. I have vertical asymptote at 1. They have a horizontal asymptote y equal 1. Y equal 1. Okay. Now I will check the graph before -2. If we take a value f of -2, you get what? 4 over 1, which is 4. So it's above y equal 1. So it will be something here in this side. And it will do what? Before -1, it will be increasing and concave up. So it'll do something like this. And these are the asymptotes. Between -1 and 0, it's concave down and decreasing, but also it will reach this. So it's concave down and increasing. Then it will be concave down and decreasing, so it will do something like this. The same thing, concave up and increasing, so it should be here. And this will give us the graph of this one. Yeah, let me finish by this one. This one I need to do the calculations completely. No asymptotes here. Intercepts, x-intercepts. I have 0, 0. Y-intercept, I have 0, 0. No asymptotes because this cannot be equal to 0. So I'll do f prime. That will be what? 3x squared times x squared plus 1 minus 2x times x cubed over x squared plus 1 squared. That will give me what? 3x to the power 4 minus 2x to the power 4. That will be x to the power 4 plus 3x squared over this. Am I right? Yeah, 3x squared times this minus 2x times this. That will be, yeah, x to the power 4 plus 3x squared. And that gives me what? X squared plus 3 over x squared plus 1 squared. Yeah, you need the intervals of concavity and inflection points for this function. Yeah, I need the second derivative. I'm not looking for the graph of the function. I need just... another way to do it easier than this. Maybe I can do it easier by making it products. So instead of doing it this way, which I think will make the calculations complicated a little bit, I'll make it this way. So now do f prime will be what? Will be 3x squared times this plus x cubed times minus, now that will become minus x squared plus 1 to the power minus 2 times 2x. So I can take x squared times x squared plus 1 to the power minus 1 as a common factor, minus 2, minus 2. And they have what? 3 x squared plus 1. Okay. Here I have what? Minus 2x minus 2x squared. Yeah. Minus 2x squared. Correct? You have 3x squared times this one minus x cubed, derivative of this, which is minus x squared plus 1 to the minus 2 times 2x. Yeah. So that will give me what now? I took x squared plus 1 to the power minus half. I'm just checking, huh? 3 x squared plus 1. Multiply, you get this one. And I have here minus 2x squared minus 2x to the power 4 times this one. That's correct. So that gives me x squared, 3x squared minus 2x squared. That will be x squared plus 3 over this. Okay, let me do f double prime. I don't know. Yeah, both are correct, but this is another way to do it. Still, I need to do this, which is a little bit complicated now. I have derivative of the numerator, which is a product. So I have 2x, x squared plus 3, plus 2x times x squared. All of this times the numerator. Okay, derivative of this, huh? Or don't make it very complicated. This one is what? X to the power 4 plus 3x squared over this. Yeah, I think this will be easier now. That will be what? 4x cubed plus 6x times the denominator minus. This one is what? 2x squared plus 1 times 2x times the numerator. All over this to the power 4. In the numerator, I can take what common factor? I can take 2x times x squared plus 1 as a common factor. What is the remaining? The remaining is what? If we take the remaining, I have what? 2x, that means 2x squared plus 3 phi x squared plus 1 minus, I have 2x and x squared minus 2 x to the power 4 plus 3x squared. Calculation. Well, this is 3, this is cancelled. So the remaining is what? 2x times this. This is what? Yeah, be careful. 2x to the power 4. 3x squared plus 2x squared plus 5x squared plus 3 minus 2x to the power 4 minus 6x squared. Okay, we are there. So this will be what? 2x. Alhamdulillah, this is cancelled. I have 3 minus x squared over this. So I'll put now the values. I have minus the square root of 3, 0, and the square root of 3. Because I need f double prime equal to 0. This is cannot be 0, so I don't care about it. Take minus 2, that will be negative. Here is always positive, huh? Who cares? Minus 2, that will be negative. 3 minus 4, that will be negative also, that will be plus. Minus 3 and 0, take minus 1, that will be negative, plus, that will be negative. After 0, take 1, positive, that will be positive. More than square root of 3, like 2, it will be what? Negative. So it's concave up, concave down, concave up, concave down. And inflection point, yes, I have inflection point here. I have inflection point here, and I have inflection point here. Okay, I think this is enough. Now, after that, we'll go to the multiple choice questions. Okay, I think this will be enough to understand the basic of this section. Let me stop the recording. Thank you.